All right, the next colligative property is the osmotic pressure. The osmotic pressure is the minimum pressure required to stop osmosis. So naturally the question is, what's osmosis? So osmosis is the travel of water through a semi-permeable membrane towards the side with a more concentrated solution. So this is pretty cool. You can take some kind of solution. Usually they put it in a tube, but you don't have to put it in a tube. It doesn't really matter. You put some kind of semi-permeable membrane. Like the one that's found in your cells. Semi-permeable membrane, this will let water through, but not solutes. So you do that, you fill it up with water, and naturally the two tubes will be of equal height, and that makes sense, right? Next thing you do, you want to add some solute on one side. And what's going to happen? Well, entropy is going to favor mixing. It's going to want to dilute that solution. So whichever side that you put the solute on, the water will travel to that side. And so it'll go to a higher level than the pure solvent size. So we'll say that the water flows to mix the solution. Right, and again, this is all entropy favoring mixing. You'll learn about that in Chem 102. And so what's osmotic pressure? So osmotic pressure is basically measuring the pressure that this creates when it does it, or really the pressure to stop it. But they're basically the same thing. The equation for osmotic pressure, it gets this capital pi symbol. It's equal to mRT, right? So this is osmotic pressure. M is the molarity, right, which is equal to the moles of the solute over liters of solution. R is our good old gas constant, 0.0821 liters, atmospheres, moles, Kelvin. And then our T is our temperature. And since our R is in Kelvin, this temperature must also be in Kelvin. If you think about the units in molarity, the moles and the liters will cancel out from our R, moles and our liters, and then our K will also cancel out, and we'll be left with atmospheres, which is a unit of pressure, so that makes sense. Again, these are plug and chug problems. See your textbook for some examples. This is also how reverse osmosis works. So in reverse osmosis, basically what they do is they apply a lot of pressure to the salty side of the solution, and then they'll push basically pure water through some kind of membrane. And so that's how one way to purify water.